your new assignments. But we have already committed in DS academic calendar for your presentation. I am on the way to Punta due to some visit of past chief. I will listen your presentation and the participant will enjoy your presentation. I will not take more time. I will request Dr. Ahmad Imran Hanjra, working as associate professor in the university, Rawalpindi University. He served Arid University for a couple of years as a lecturer and assistant professor, then did his postdoc from New Zealand. He is very good in the sector of management sciences, especially
अब आज तुम हालत देखती ना इतनी गंदी हालत थी अब जाके तुम टेरेस को देखो
I will request Dr. Ahmad Imran Anjara to start his presentation. It will about 30 to 40 minutes. Then we have the 5 questions on the session. I will try to connect after the presentation, but if I have some signal issue, Dr. Ahmad Imran, please, you can conclude the session. I will stay online.
Okay, Dr. Sahab, thank you very much. Thank you very much for inviting me in this wonderful series of webinar. And I must appreciate your effort to improve the research skills of our scholars as well as early career researchers. And it's a wonderful
excuse
webinar.
Me, data center may allow the Ahmad Imran Hanjra to share screen.
डॉक्टर साहब अलाउ कर दीजिए स्क्रीन शेयर.
Okay, is it visible? My screen is visible to you?
Yes, डॉक्टर साहब नजर आ रही है.
Okay. Thank you very much, Dr. Sahab, for inviting me this wonderful session, and I must appreciate your effort towards the improvement of research skills of our students as well as scholars and early career researcher. And this webinar is related to the implications of advanced analytical techniques in social sciences. As we all are, we normally, I'll be talking about my department, that is management sciences and social sciences, which is having a lot of sub-departments, and how the social sciences advanced analytical techniques are important for social sciences. So here is the brief outline of today's webinar. First of all, we'll be starting from the nature of data, then what is the importance of analytical techniques, then we can move forward towards scale of measurement or instrument, then how we can validate the instrument for data collection, and then we can check if there are some missing values, how we can manage the missing values, then reliability and normality of data. Then we can talk about the descriptive stat and inferential stat, how these, because our webinar is focusing on analytical techniques and we're falling under 2 heads, descriptive stat and inferential stat. There will be measure of differences, there might be hypothesis testing and so on. So at the end, I'll be talking about the mediation analysis. If there is indirect paths, then how we can run the analysis. Here is some important quotes by top scholars in the field, how analytical techniques are important. The first is the examined life is not worth living. It's stated by Scott that unexamined life is not worth living. It means they are focusing on the empirical side. If it's not tested, knowledge is not tested, that is not worth living. Everything must be taken into account. If the fact will not fit the theory, let the theory go. That is also the claim of, again, thought. It is a capital mistake to theorize before one has data. if we make some facts and figure based on the data, then we can justify the theory. And it is stated by Arthur. Knowing is not enough, we must apply. That is obviously talking about the applied side. That's Bruce Lee. Data, data, he cried impatiently that I can't make bricks without clay. Obviously, data, if there is data, then we'll be talking about analytical techniques. Yeah, and these techniques can be qualitative techniques and quantitative techniques. We can go for the qualitative data and quantitative data. There are 50 who can reason synthetically, for one who can reason analytically. It's very clear that analytically there are threshold values, cutoff points, there are rational decisions, and there will be no subjectivity if we are talking about analytically as compared to synthetically. First, I will start my discussion from the nature of data. As we all know that there are two types of data. One is qualitative and second one is quantitative. If we look at the types of research, one is basic research, second one is applied research. If we are going for basic research, it means the nature of data will be qualitative, that will be exploratory research, and nature of data will be qualitative. If we are going for applied research, the nature of data will be quantitative, and there are three different types of quantitative data, classification of quantitative data, starting from cross-sectional data, then time series data, then panel or pool data. Our webinar is related to quantitative techniques in social sciences, and normally in social sciences we choose cross-sectional data. And as you know, cross-sectional data is if once the data is collected from single time period from several individuals, that is called cross-sectional data. As you know, that time series data is also number of time periods are more than one, and the for a specific individual. Panel or pool data. Panel data is mixture of cross-sectional and time series. It means there are several number of time periods, several number of cross-sections, but the arrangement data is from time series to cross-sectional. And then there is pool data. It's also cross-sectional combination of cross-sectional and time series, but the arrangement is cross-section to time series. This is very basic. Then, as I stated, I'll be talking about more related to social sciences analytical techniques, and we normally use in social sciences the cross-sectional data, and cross-sectional data is a primary source, is measured through primary source, and primary source data. For primary data, we are required an instrument. And instrument, what is instrument? Instrument is a tool which is used to collect the data, primary data, and it is collected through questionnaires, it's collected through interviews and observation. And obviously, if we are talking about instrument, instrument, that is a tool for data collection, and it should be valid. And in an instrument, we have different scales. Normally, our scholars know that there are 4 types of scales, starting from nominal scale, ordinal scale, interval scale, and ratio scale. And this scale determines the amount of information contained in the data. The scale indicates the data summarization and statistical analysis that are most appropriate with different types of scale. So ratio scale, when exact numbers are given, then we normally go for the ratio scales, interval scales. It is normally used to measure the perception, judgment, and if there are various items of a particular variable, then we normally use 5-point or Likert, 5-point or 7-point Likert scale. It's about it's about to measure the judgment, perception, and understanding related to a particular variable of your research. And ordinal scale, when there are preferences, if we focus on the word that is ordinal, Ordinal means order. When preferences are important, preferences are given, we normally use ordinal scale. The nominal scale is used for personal information like gender, age, your CGPA, your income. If there are personal information are given, then we apply the nominal scale. As I stated in my earlier slides, that we are talking about social sciences, and in social sciences, normally we collect the cross-sectional data through an instrument. And what is an instrument? Instrument is a tool to measure the data. If, first of all, instrument should be valid. If instrument is not valid, it's not related, it's not reliable, obviously data will be invalid. There will be no reliability in data, then there will be abnormality in data, and theory and application will be not aligned if questionnaire, our questionnaire or measurement is not valid. As we know, there are two types of measurement to validate the instrument. First is subjective measures. It means here we talk about content or face validity of the questionnaire or our instrument. And second one is numerical measure, which is normally distributed or differentiated in two further categories. One is explanatory factor analysis, and second one is confirmatory factor analysis. And I will briefly discuss these components in our preceding slides. Here, the extent to which the content of item is consistent with the construct definition. If we look at this face, it means by look, by definition, by understanding, by expression, the variable must represent the definition or characteristics of the variable. It means our items or questions must represent the basic characteristics of variable. It totally based on the researcher judgment. And who can check the content or face validity of the instrument or questionnaire? It means obviously an expert of the specific area can check the face or content validity. It's totally subjective measure, and it varies from expert to expert, but there will be there might be some variation in the understanding of the expert of the area. Then the second one is numerical mirrors. In numerical mirrors, there are some threshold values, numerical values, which are used to make the final decision either our instrument is valid or not valid. Here I have, as we know that it's differentiated in two categories. One is exploratory factor analysis. Second one is confirmatory factor analysis. If we focus on the word that is exploratory, it means when you are going to explore something new, it means you are going to introduce some new variable. Obviously, the nature of variable data will be primary data, because we are talking about instrument, and we have to introduce new instrument, and new instrument should be valid, because exploratory factor analysis, here we are talking about the new instrument. We are going to introduce something new in the body of knowledge, which has not been tested before. If it's not been tested before, obviously we must have to introduce its new measure, and new measure should be valid. First of all, expert of the area will check its validity. Later on, we can check the exploratory factor analysis, which is comprised by 4 components. And these components, these are, as I stated, as I discussed, that these are numerical measures. Here will be some threshold value which can be used to check the validity of instrument. Here we can make the decision either threshold value, either it's valid or not valid. There will be no subjectivity between the experts, because there is a cutoff point. Cutoff points will differentiate either it's valid or not valid. Normally, 4 components are used to check the validity of instrument while we are going for exploratory factor analysis. And when we apply exploratory factor analysis, if we are introducing something new, if we are introducing some new measure, then we go for the exploratory factor analysis. And there are 4 components: extraction value or load factors, then KMO and Bartlett test, total variance explained, and Secchi plot. These are the major components which are used to check the exploratory factor analysis. Actually, we have a limited time. We can't discuss in detail what will be the cutoff point of extraction value, KMO and Bartlett test, when it will be used, what does it mean, the total variance explained, and Secchi plot. And it's a work of a couple of days or 3 days workshop. Then we can go in detail to practice, to make the in-depth understanding how we analyze, how we can run these tests in the software, and then how we can make the analysis, how we can make the decisions. Second is confirmatory factor analysis. After the exploratory factor analysis of newly developed instrument, then we can go for the confirmatory factor analysis, CFA, and is another process to validate the instrument. Here, I will must differentiate that if you are adopting the instrument or adapted the instrument from the previous study, when we adapt or adopt the instrument, if you are going to test a variable which has been already available, which is already available in the literature, and it's not new variable, and you are going to test that variable in our scenario, and then here the geographical there are geographical differences, perceptual differences, environment different, approaches different, then we can go for the confirmatory factor analysis. We can confirm the instrument through confirmatory factor analysis. Normally it is used when we adopt an instrument from the literature, then we can go for the confirmatory factor analysis. It also checks the goodness fit of the model, discloses the measurement error in the model. Here are different scholars, they state that CFA is the best method to understand either the questions, items, or statements have strong interest or not to explain the variable in a particular scenario. There are different threshold values, or there are different components which are used, which are normally included in CFA. In order to check the validity of instrument and model fit indexes is used, we normally use construct validity, and which is measured through convergent validity, and convergent validity is having for the 3 parts: factor loading, AVE, average variance extraction, and construct reliability. They all are having their cutoff points. Then we can make the decision. Discriminant validity, when you have more than one independent variables, and as we know that all independent variables are different in their nature, in their description, in their conceptualization, obviously they should be different, numerically different to each other. While you are going to test these variable, then we can check the discriminant validity of those variables. And next is nomological validity. Nomological validity is also used either one is numerical relation, second one is logical relation. Either logical relation between 2 variables. Suppose if 2 variables are positive related to each other, then their association calculated through correlation should be positive. The direction of causality, direction of relationship should be positive, because by conceptualization, by understanding, if though two variables are positive, obviously their correlation, their relationship should be positive. That is called nomological validity. Next is structural equation, structural model. Here we normally talk about the goodness fit indexes. There are several models, 20+ models, but widely used in social sciences research are primary data research. There are 5. 5 to 10 different models which are used in social science research, like chi-square, Remise goodness fit indexes, adjusted goodness fit indexes, norm fit indexes, and so on. And this is the table which normally tells us the rule of thumb between the models, which of the model is perfect fit, excellent fit, reasonable fit, or poor fit. And as I stated, we normally use these 5 criteria while making the decision. Either your model is best fit, reasonable fit, or poor fit. There are cutoff points. If chi-square is between less than 3, between 1 to 3, we can say that is an excellent fit model. Poor fit 3 to 5, if it exceeds 3, that is perfect. Reasonable fit, that is acceptable. When it's poor fit, if the chi-square value is greater than 5. Same as the criteria with goodness fit indexes here. Once we have the good GFI value greater than 0.95, that will be excellent fit. 0.90, that will be reasonable fit. And if less than 0.9, that will be perfect. Same as the adjusted goodness fit indexes, comparative fit index, and error, root mean square error of approximation. If the value of error term or remise is less than 5%, then model is excellent fit. 5%, 6% to 8%. Here I'm not talking about acceptance or rejection of a hypothesis. Here we are talking about the error value, remise value. If it's between 0.6 to 0.8, that is reasonable fit. If it's greater than 10, 10% means 0.10, the obviously model will be the poor fit. If model is poor fit or not good fit, then how we can diagnose the problem? What is the problem? How we can determine the problem which is causing the poor fit of our model? In addition to evaluating good fit indexes, statistics, the following diagnostic measures are used in CFA. First is path estimates. We can check the path estimates. If any of the item is having load factor less than a threshold value, we can exclude it simply. We can put the connectors between the among the error terms, having the items having high error terms, we can put the connectors. Obviously, it will take average, that will accumulate it, and it can increase, the error will be decreased and goodness fit will be increased. Then we can use standardized residual covariance methods to improve the goodness fit of our model. Here, after validating the instrument, then we can go for the data collection. During data collection, once you have done with your data collection, then there might be some missing values, and how we can treat with missing values. And there are some suggestions, some points which can be used to treat the missing values. If there are 5% missing values, or we can say 5% respondents didn't reply or given respond to total sample, then replace missing values. We can treat by ourselves. We're taking the mean of upper 5 and lower 5 values of missing values. Very simple. If missing value, if there is or 5% missing value, we can take the mean of upper 5 and below 5 of a missing value, and we can replace it. If the missing values response is between 5% to 25%, then we can revisit the respondents, which the respondents who didn't give their response, and we can request them and we can take their response. Then if it's more than 25% missing values, it means we have a serious problem. Then revisit yourself and your instrument, and what is wrong in our instrument, why the respondents are reluctant to give us the response towards our instrument. It means there is something serious, or you might be having some personal questions, there might be some complex questions, which are beyond the level of correspondence, or you can translate the questions as per the understanding of respondents. Once you have done with the data collection, or after adjusting missing value, we can go for the reliability analysis. Reliability analysis is normally used to check the generalizability of our respondents. It also tells the understanding level, maturity level, or maturity level of the respondents. Either our respondents has understand the questions which we are going to ask them. If they are their response is not consistent, then we can say there is something serious in our collected data that is not reliable. If data is not reliable, then how we can test our hypothesis, how we can make the decision based on the data which is not reliable. We can check the internal consistency. Internal consistency scale is used, and reliability is checked through Crown Batch Alpha, and its limit is 0 to 1. And if it's more than 0.7, or some scholars also states that 0.6 is also fine to refine to check the reliability of our data. After going through the reliability of data, we have the normality of data. There are two criteria to check the normality of data. There fewer some lenient criteria, and there are fewer some very rigid in their decision making. Normality of the study variable, scale variable should be checked. We can name as the test of homogeneity. There might be normal or abnormal data, but most of the time data is abnormal. And if we talk about the cross-sectional data, and we normally use this hypothesis, there is no significant difference in the variance of data. It means no significant difference. It means data is normal. Difference, there is less difference between the observations. It means they are very close to each other. There is no extreme values. There are no extreme values. There is no ups and downs in the data. If there are no ups and downs in the data, data is not highly volatile, or highly if there is no high variation in the data, it means data is normal. If there is a significant difference, it means one value is here, second value is here, there is there are significant differences. It means there are outliers in the data. Obviously data will be abnormal. We use descriptive measures like mean, standard deviation, skewness, kurtosis. These are a bit lenient criteria to check the normality of data, and we can use the normal distribution curve histogram to check the normality of data. But there are some conservative approaches, very strict in the decision making, like Kolmogorov and Shapiro-Walk. There are different criteria which are used to check the normality of data. If the sample size is less than 50, we consider Shapiro-Walk, and if sample size is greater than 50, we go for the Kolmogorov and check the normality of data. Here we will be making the decision on the basis of p-value. If p-value is significant, it means yes. P-value is significant, it means yes. What is yes? Yes, there is difference between the variance of data. If variance of data, there is a significant difference, it means data is abnormal. We have to then check the data. After checking the normality of data, we normally go for the descriptive statistics, and descriptive statistics are used to check the strength of the responses of the respondents about the question. And descriptive stats we normally imply in our social sciences. We normally use mean, measure of differences, and measure of dispersions. In measure of dispersions, we normally use standard deviation, range, skewness, and in central tendency or measure of central tendency measures, we normally use mean, median, mode, kurtosis, and frequency distribution. These are the widely reported components from the descriptive stat in our analysis of primary data. Here is a research designed to understand the oral discussion which I have made. If your research is exploratory, it means we are talking about basic research. What does it mean? We are going to explore something new in the body of knowledge. Then the nature of data will be qualitative. Nature of data will be qualitative. Okay. And when body of knowledge is known, when the body of knowledge is unknown, qualitative, it means we are going to explore. Obviously, there is something new in the body. We want to explore something new in the body of knowledge. It means that is unknown. And what kind of instrument we'll be using? That will be open-ended instrument, open-ended questionnaire we use to collect the data. If the nature of data is qualitative, here will be not putting the restricting the respondent between few options. When we go for the qualitative data, if your nature of research is exploratory, if you want to explore something new in the body of knowledge, then the instrument will be open-ended. Second one is descriptive. Here we are talking about the applied side. Descriptive means to describe facts and figure, and the nature of that will be quantitative. I was normally focusing on quantitative side. And when the body of knowledge is known, but there is a problem related to the practical implications of the existing knowledge, then the instrument which will be used will be close-ended questionnaire. That is the descriptive and a descriptive type. If our research is hypothetical testing and we are having some forecasting statements, we want to check the impact of one A on B, then we can go for the hypothesis testing. And there are two further heads. One is measure of differences. Second one is measure of association. Just focus on the word differences. It means we have different groups, and either the understanding of those groups is significantly differ to each other or not. Obviously, if we are going to check the differences between the perception or judgment of respondents related to some particular variables, then we can go for the measure of differences. And measure of association, here you are going to check the association between two variables, two or more than two variables. These are normally called non-parametric tests, and these are called parametric tests. There might be one sample, there might be independent sample, there might be multi-sample. If there is one sample, we can go for the one sample t-test. One sample I will a bit explain in my preceding slides. And independent sample, it means the characteristics of interest are different from different, there are different groups, like suppose gender, age, experience, then we can go for independent sample t-test. If there are multi-samples, we can go for the ANOVA. It can be one-way ANOVA, two-way ANOVA, and so on. And when we can go for the one-way ANOVA, then we can go for the one sample t-test, independent sample t-test, mean differences. We have different characteristics of our statement. Then we can go for the particular component, particular analysis related to our question. Measure of association, there are two cases. One is dependency cases, second one is interdependency cases. Dependency means once one thing is depending on another thing, it means independent variable and dependent variable. One thing is impacting on the two other things. One variable is impacting on other variable. So there will be the case of dependent and independent. If there is one dependent variable and one independent variable, that is called causal relation, and we apply normally simple regression. If there are more than one independent variables and one dependent variable, that is called correlational, and we apply we apply multiple regression. If there are multiple DVs, multiple IVs, multiple DVs, then we can go for Mankova and Manova. They are different. They all are having their different characteristics by their with respect to the nature of our questions, our query, or objective in our research thesis or research paper. So interdependency means interdependency. If we focus on the word that is correlation, how the variables are related to each other, it means we can go for either Pearson correlation or Spearman correlation. This is the overall picture of overall design once we have quantitative data and the nature is cross-sectional. Major difference is that these are called parametric tests. These tests are applied when the demographic variables are compared, are also called comparative, and we can go for the comparative analysis. We can apply one sample t-test, we can go for independent sample t-test, paired sample t-test, one-way ANOVA. I have explained in my previous slides in detail. So correlation analysis, it's the case of interdependency. When we have more than one independent variable, we can check the correlation analysis, and it's normally used to check the association between two variables, and we widely use to check the multicollinearity in our data. Limit is plus minus 1. The value near to 1 is called strong association between two variables. It is near to 0. That is called weak association, as you know this before. Regression, as it stated in previous slide, regression is used, that is a dependency case, not interdependency. It means we are going to check the impact of one variable on another variable. Here we go for the hypothesis testing. If you are having hypothesis in your research theoretical framework, we go for the regression analysis. It can be single regression, it can be multiple regression, it can be direct regression, and it can be indirect regression. If we have indirect regression, we normally go for the structural equation modeling. Structural equation modeling is normally used if you want to publish in top tier journal. I have published many research papers by utilizing the structural equation modeling, like Journal of Finance Research Letters, Journal of Forecasting and Social Change. We have published a lot of papers. They are journals having high impact factors. So there will be some dependent variable, endogenous variable, exogenous variable, mediators, moderators, and you can go for the structural equation modeling by taking the 95% confidence level and 5% significance level. If there is indirect relation, there are two steps. First, we check the direct relation. In second step, we check the indirect relation by incorporating the independent variable, the mediator variable, and then we can make the comparison between the coefficients of direct model and indirect model and make the decision either there is a mediation or full mediation or partial mediation. There are different econometricians. They have given the threshold values of cutoff point to make the decision. Here I will take an example. What is an example? That is a theoretical framework which is related to variable, independent variable A, independent variable 2. There is a mediator, there is a dependent variable, and we can construct the hypothesis. First step is impact of IV on DV. Here we can check the correlation coefficients, and we can make the decision on the basis of p-value. If significant, our hypothesis supported. If not significant, hypothesis not supported. And this is the indirect model. Here, if we look at the indirect model, mediator is incorporated between IVs and DVs, and we can check the make the decision based on the p-values, and then we can check the make the comparison between the coefficients of IV and DV. It's the direct model. It's the indirect model. What is direct model? Indirect model, there is no mediator, but in the indirect model, there is a mediator. What is the decision? If the coefficient is decreased after incorporating the mediator, look at the coefficient, that is 0.46. Once mediator is incorporated, the coefficient becomes 0.46 to 0.404, and it's insignificant. That is called full mediation. If we look at the second variable, the coefficient is 0.26, and after incorporating the mediator, coefficient is decreased and still it's insignificant. That is full mediation. That was a brief, I think, the example of mediating analysis. Here is something golden rule. You keep on learning, and pretty soon you will learn something new which no one has learned. This is quotation. It always motivates me to work again, learn. So here is another read it. Go back and read again. Obviously, you will be getting in-depth understanding. So this is the all about today webinar. If you have some question or queries, I'll be more than happy to give you answer if I understand. I have the understanding of your queries. May I ask the admin to unmute Dr. Ziaur Rahman? He has, I think, some question.
सर डॉक्टर साहब आप अपना माइक
Dr. Sir, thank you very much for. I am on the way. I requested Dr. Zia from UAM. He will moderate for question answer session and conclusion.
Dr. Zia, can you unmute your mic and you can moderate?
Please, data center guy, please unmute the mic of Dr. Zia.
सर जी डॉक्टर जिया साहब अनम्यूट कर सकते हैं माइक अपना मैं राइट दे दी उन्हें
Dr. Zia, are you there? Okay, any other participant having question? Or you can write me if you have any question at my email. I'll be more than happy to respond. Assalamu alaikum.
Hello, Dr. Saab.
Assalamu alaikum, Dr. Saab. Can you
Am I
hear me?
audible?
Yes.
Yes, Dr. Saab, I am really grateful on behalf of Directorate of Advanced Studies and Director Advanced Studies as well, Dr. Mohammad Azam Khan. He is busy somewhere in meeting, so he is unable to conclude the session. So he just asked me to thank Dr. Ahmed Imran Hanjara Saab to spare such a precious time for our students, for our university. So I am really grateful on behalf of Arid Agriculture University and specifically on behalf of UIMS, that is your X department. So I'm really grateful for your time and efforts. And it was really an amazing session because the way you sum up the course of almost 2 semesters in one sitting. So it is really amazing for all of us. So it is a learning experience for the students of University Institute of Management Sciences, for me and rest of the students of the university. So once again, I am really grateful. And if some student want to ask any question, so you are most welcome. The house is open for questions. Please raise your hand if you want to ask any question. Yes, students, please. Okay, students can watch the recorded video on the YouTube channel of Directorate of Advanced Studies afterwards as well. So I think today's seminar was as per the number of participants is concerned. So it is, I think, the best one among all the seminars already conducted by the Directorate of Advanced Studies. So the overwhelming response to this seminar actually shows the standing of Dr. Ahmed Imran Hanjra Saab in the research in the field of management sciences. So we are actually, Dr. Ahmed Imran is inspiration for all of us in the field of research and specifically in management sciences.
Sir, thank you very much for these nice words. I'm always, it's always pleasure for me to serve for my parent university, that is Arid Agriculture University, and specific to UMS, because I started my career there and it gave us the platform and provided everything to groom our research skills. And I will always love to be part of this type of activities at my parent university. Thank you very much for engaging me in this wonderful.
Dr. Sir, we always miss you, and we always will be missing you. And you are still part of us because of this virtual world. We'll keep on engaging you in other platforms as well. Thank you very much, Dr. Sir, once again. See you, inshallah. Thank you for all the participants. Okay, ji admin, over to you.